We are recording our section 1-2 notes for geometry, and I am on page 7 in my geometry book. I am doing a few videos today, so as I mentioned in the previous one, I am working from home. It is a Sunday afternoon. My dog just walked right through the kitchen, and I have laundry going, so you might hear some background noise. We're going to move forward in section 1-2. So again, normally what I would do is I would ask you guys questions and you would contribute, and we can't do that because we're doing learning videos that are remote. So here we go. Problem number 1 on page 7, section 1-2, asks us to draw 4 angles with different characteristics and describe each angle. Okay, we're going to name them using numbers and letters. So I'm going to start off with this guy. And I'm going to make that very special. Now remember, when you're sketching something, it's not always going to be perfect. So that's why we have to label things so that we can communicate what we're trying to show. I'm going to put a little box right there. I'm hoping you remember what that little box means. That means that this is a right angle at 90 degrees. And I'm going to put a point here. I'm going to name that A, and then B, and then C, because I'm a boring math teacher, and that is how it works. I could name this angle B, or angle ABC, or angle CBA. There's one. Let's see what else I can do. Ooh, I'm going to do this one, and I'm just going to give this the number 1. Notice how skinny and narrow that is? That has a special name. This is what we call an acute angle. Angle number 1. You might be wondering, well, what does an acute angle mean? This is an angle that is less than 90 degrees. Okay, well, I am going to do a different type of angle. I'm going to do a really wide one. And I'm just going to call this point D right there at that vertex. This is angle D, and this is what we would call obtuse. Obtuse means that it is more than 90 degrees. Now you might be thinking, well, what else is there? We've got 90, right angle. We've got acute, smaller than 90, obtuse, greater than 90. And this is the one that people tend to forget and that I can never draw very well. Pretend that was a straight line. So this right here is what we would call a straight line or a straight angle, and it's 180 degrees. So this is going to seem weird. I could actually call this, I'm going to name this E, F, and G, angle EFG, even though it feels like a line because it's a line, but we could take an angle and just flatten that out, and we've got it. So let's talk about this next section. It deals with compare and contrast, and so there's a little side note over here. Compare and contrast says, with two figures, how are they alike? How are they different? So on number 2, part A, I see 2 angles, but angle number 1 is small. That's acute. Angle number 2 is obtuse. And hopefully there we go, that focuses. And if you notice, angle number 1 and angle number 2 make a straight, oops, if I could spell, a straight line. That might be something of interest. So one's bigger, one's smaller, and together they make a straight line. Well, here on picture lowercase b, I'm hoping you guys can see 3 different angles. We can see angle A, D, B. Right in here I'll do stripes. I can see angle C, D, B. I'm going to do polka dots. And then I see angle A, D, C, which is a right angle. Now these 2 in here, these are both acute. They're both smaller than 90 degrees. But these 2 together create a right angle. Well, that's going to be important to us. Let's keep going. Let's take a look at angle C, picture C, angle DEF, and angle RST. Both are acute. And something I want you to notice. You notice that if we were to add these two together, the measure of the angle on the inside, 30 degrees plus 60 degrees, that's 90 degrees. Now that's really important, and we're going to write that down in just a second. I'm going to scoot this a little bit. I'm going to angle my camera. Whoops, I think I angled it the wrong way. Oh, I'm sorry. You can see the freckles on my arm there. Okay, let's take a look here at picture D. I think this angle right here is acute. This guy's more than 90, so that's obtuse. But something I want you to think about. If we take 30 degrees plus 150 degrees, if we were to add them together, we would get 180 degrees, which is the measure of a straight line. This is kind of important. So I want you to come over here. Put a little star. If we have two angles that add to be 90 degrees, we call them complementary. And you might be, I want to make sure I spell this right. Is it A-R-Y or E-R-Y? It's A-R-Y. We call them complementary angles. Now you might be thinking, when I think of a compliment, it means someone said something nice to me. Okay, well, these are two angles that add together to be something nice. They add to be 90 degrees. These two down here, we call them, I'm going to put another star, double star. These two are what we call supplementary. Hard to write on the edge of my book. Supplementary angles. That's an E and an S, if you can see it. That's when two angles add to be 180 degrees. So let's go to the page and see what else we have. Notice over here on the side we have a math tip. That's where a lot of our vocabulary and definitions will appear. And it says an acute angle measures greater than 0 degrees, because if you have 0 degrees, it doesn't open into anything, and less than 90. A right angle measures 90, obtuse greater than, and a straight angle measures 180. I'm going to step away for just a second. I want to grab a highlighter. If I were at my desk at work, I'd have highlighters right in front of me, but I'm at home and they're in the drawer. Oh, can you guys hear that? My laundry's done. So I want you guys to focus on this box, maybe highlight it, do something special in your book so you can find it. Up here on the top of page 8, we have the definition of complementary angles. So the sum of measures of complementary angles is 90, and the sum of measures of supplementary angles is 180, and that's what we wrote down on the previous page. Now I want to bring your attention to some different looking angles. And I'm going to zoom in a bit. So notice how these angles make, get my hands right, an X. Not quite used to my equipment. It's been a summer, a long summer since I've used it. So there are some interesting things in this picture. Notice angle 3 and angle 5. Angle 3, and if I write down the 3, that would help. Angle 5, they have the same measure. If you look at angle 4 and angle 6, they have the same measure. So what's going on with that? Well, this is what we call vertical angles. So I'm writing at a slant here. I almost said at an angle, but I didn't want to be that punny because, you know, math jokes are pretty lame. These are what we call vertical angles. So the opposite angles are the same size. That's kind of nifty. So when we take a look right here at angle 7 and angle 10, they're going to be congruent to each other. They're the same measure. If you're wondering, what is congruent? Congruent basically means the same. So complete the chart by naming all the listed angle types in each figure. Okay, let's take a look right here at 7, 8, 9, and 10. Acute angles are less than 90 degrees. So I'm going to go with angle 8 and angle 9, and these two are the same measure. I'm going to say obtuse angles more than 90, angle 7 and angle 10. And I'm going to circle them because they're the same measure. Ooh, hey, angles with the same measure. Angle 8 and angle 9 because they're vertical, angle 7 and angle 10 because they are vertical. Let's pause on supplementary and complementary. Let's pop over here to this picture, acute angles. Now this one's going to be a little more challenging on creating those acute angles because we don't just have numbers, we have letters. And I can't talk about angle B because there's a ton of angles. 1, 2, 3, 4, 5. And if we start going through multiples, holy cow, we can't do that. So we have to be very, very specific. I'm going to do something with my book here to make it just a little bit easier for me to write, hoping that's still within your view. So with this, let's talk about acute angles, less than 90 degrees. So I'm going to go in here, and I'm going to put a little star where I see an acute angle. Angle D, B, C. Notice how B is in the middle because that's the vertex, and D and C are each used because they're on each one of the rays. Could we do DBE? Yes. That is also acute. We can't do this guy down here. That's more than 90 degrees. So let's label that as obtuse. Angle EBF. Let's take a look at this one. FBA. That's less than 90. What about this one on the left? Is that acute or obtuse? And I wish someone could tell me an answer, but I can't hear you or see you. So the answer is no, it's a right angle. Now some of you might be looking at this in a very different way. I want to look at a new obtuse angle here. I'm going to use my highlighter. What about that? Hoping you guys can see that in yellow. Oh yeah, now you can. That angle is obtuse. Couldn't we do angle CBF? Yeah. And could we do, oh boy, could we do DBA? Yes. Interesting. We typically don't describe angles that go more than 180 degrees. We typically look at the smaller of the pieces of the angles, so angles are from 0 to 180. Can't talk about like ABE because it's a straight line, or FBD, but looking at these two, you can get a little creative and start looking and thinking. Okay, angles with the same measure. I want you guys to check out this 90-degree angle. Can we look at angle ABC? Isn't that also the same as angle CBE? They both together make 180 degrees. They're each 90 degrees. Now, some of you guys might be looking at this like, there's another set that's the same. What about angle ABE? That flat line. Are there any other straight lines? Angle FBD. Interesting. Okay. So let's talk a little bit about supplementary and complementary angles. And we also have some topics talking about chords and circles. So this video is probably going to be closer to 18 minutes, and I'm sorry, but we're still learning language. So supplementary angles, remember they add to make 180. Well, I kind of need to keep a picture in here. Can we agree that angle 8 and angle 7 together make a straight line? Ooh. Angle 7 and angle 9, also a straight line. Angle 9 and angle 10. And then angle 8 and angle 10. Those are each supplementary because they make a straight line. So remember, supplementary, 180 degrees. Complementary, 90. There's nothing in here that's going to add to make 90, so we're going to cross it off. We don't want to leave it blank. We just want to show that it doesn't work for us. Now let's look at this one. There's going to be a few supplementary angles. Could we look at this straight line right here and say angle ABC and angle CBE? Together they make 180 degrees. Could we do angle ABF and angle FBE? These two. Now, are there others? Yes. What about DBE and EBF? Yes. There might be some others as well. But when we talk about supplementary, we're just looking at 2 angles at a time, not 3. So typically I'll have students look here on the right angle, this little skinny guy, and then this one on the right. I'm like, they're supplementary. Supplementary is talking about 2 angles, not typically more than 2. There might be some others in here, but I'm going to move on. Complementary angles. Now complementary angles, this is going to be hard. I need to zoom out. I can't see everything I want you to see. Complementary angles, remember, these are 2 angles that add to make 90. I think this in here is 90 degrees. So if we were to talk about angle CDB and angle DBE, they are complements. All right, let's scoot on over and talk a little bit about circles. So the chord of a circle is a segment with both endpoints on the circle. So let's take a look at the circle. Would you guys please put in a point right there? We're going to call that the center. And we're going to start labeling some different things. So in here, it asks us, in the circle, draw and label each geometric term, a radius, a chord, and a diameter. I want to start with a chord because that's defined right up here on the very top. So a chord has both endpoints on the circle. Okay? I'm going to name that point B and point A. I'm going to check that off. A diameter is a chord that passes through the center of the circle. So a diameter is a special type of chord. Now here it asks us to name diameter CA. Well, I already have point A, so I need to come all the way across, and I have to go through the center point. So we're going to name that C, and that, oops, I didn't connect those, is our diameter. So this guy is a chord, and this in here is a diameter. Now a radius is a segment with one point on the circle and an end point at the center of the circle, and it wants us to do radius OA. Well, there's A, there's O, so this little piece is a radius. Okay. Refer to your drawings in the circle above. What is the geometric term for point O? That is our center. When we name a circle, we name a circle with the center point. And we're going to spend a lot more time on circles, but okay, we're good. Number 7, the circles below are concentric, meaning that they have the same center, so one inside the other. Explain why circle P is not an appropriate name for the smaller circle. Well, if I were to talk about circle P, which one am I addressing? The little inside one or the whole outside one? Okay, that's a problem. Circle P could mean the small inside circle or the whole bigger circle. So we would need to be more specific. So it asks us to propose an alternate name for the smaller circle that would be appropriate. And this is where I would love to be able to just kind of pause and say, hey, what do you guys think? Well, we could get really specific, but for the smaller circle, we could say circle P with a radius of PQ, and notice that's a segment. For the larger circle, we could do the same thing and then specify where am I stopping with that circle. Circle P with a radius of PR. Okay, there we go. Oh, some academic vocab. When you justify a choice, you're giving evidence, you're explaining your reasoning. That's going to be a big part of our geometry class. So my video is pushing 20 minutes, and I think I'm going to stop. I am very hopeful that you guys, oh, I lied. I'm going to do one more. I want to take a look at number 9. So the measure of angle A is 42 degrees. I'm going to do this over here. The measure of angle A equals 42. What is the measure of an angle that is complementary? So remember that complementary means that they add to make 90 degrees. So 42 plus what equals 90? Couldn't we do 90 minus 42? Oh dear. Now I have to do some quick arithmetic. Wouldn't we be talking about 48 degrees? Because 48 and 42 makes 90. For part B, supplementary means that they add to make 180. So wouldn't we say 42 degrees, and I'm going to mark this as x, because that's what math does, equals 180. And I'm going to play with this as an equation. I'm going to subtract my 42 degrees off. And I'm going to do a little, borrowing here. So I'm going to borrow that. I'm going to have an 8, 7. We'd be looking at 138 degrees for a supplementary angle. I'm sorry, guys, this video was longer than I planned, but the circles kind of extended us a little bit into that. As always, let me know if you need any help.